Okay, grade 12, welcome to our second last unit and a happy 2021. Hopefully, it'll be better than 2020. Let's try to get this finished right. Okay, so this unit is a pretty straightforward unit. I asked you guys to read a little bit about it over the break, and we're going to be talking about energy production, power plants, and alternative energy for the first half of this unit over this week. So, it's a very important theme. Uh, Big decisions, big political decisions are based on our need to have electricity. And in Ghana, we know that without electricity, we have no production, we have no Wi Fi, we have no online learning without electricity. So, such an important factor. We need to be able to generate it, and we need to be able to power our electronic devices to be able to stay connected on Zoom and do the things that we do during this lockdown period of time. So, as you can see here in this grid, there are many things that major cities will do in order to make sure that we are always connected to power. We have many varieties of methods of generating power, such as wind power, solar power. We burn fossil fuels to generate electricity that can then power electric cars. We can use electricity that we've generated to create chemicals and do other things, or heat water in our boilers. So, energy production and transformation of energy from one form to another is a very important feat that we have to do in everyday life. So, this unit first talks about what are the sources of energy that we use when we're producing electricity and power. All right. And when we take a look at what the world actually uses for energy, it's quite surprising that the majority of what we use in the world is the most polluting type of energy. Okay. 22% of what we use in the world to create electricity and to power our cars and heat our homes is natural gas. That's methane. And that's rapidly rising. More and more countries are using that as their primary source. Oil is still the number one. We use oil and oil products to power our cars in the form of fossil fuels, burning gasoline to power our cars. We also use oil in power plants to generate electricity. We use oil and the burning of oil to create heat in thermal plants. And an age old technology that we still use around the world is coal power plants. We burn a lot of coal. That is the most polluting form of energy that we can get. And coal can be found in every single country. Oil and natural gas can't be found in every single country, but coal you can find basically in the ground everywhere. So that's why it's predominantly being used. So these three types of energy sources account for, wow, more than 3/4 of all the energy we use. And then something that we all think that we use a lot of is nuclear. Well, that's only 5% of the world because not every country has it. Water is everywhere, but surprisingly, the world only uses 2% of hydroelectricity. Ghana, on the other hand, uses a lot more. So we can say that Ghana is quite advanced compared to other countries when we're talking about alternative fuel sources. And something that's becoming really big, particularly with my brother, is using biofuels or waste as energy, burning that to generate electricity and other forms. Okay, so that's what the world is doing, and you can see how much pollution is coming out of that burning of those types of fuels. On the other hand, countries that are thinking ahead and are trying to stay clean, such as Finland, this is what their percentage of energy sources are, which is quite interesting. They use 33.7% of nuclear. They're not afraid of nuclear energy. I wonder, okay, is that really polluting? Well, you'll see that it's quite clean. It's just dealing with the waste that is the issue. They use 25% hydro, that's a renewable energy with very clean source. And only 8.3% is coal and 0.3% is oil. All right, coal they can find within their own country. They have natural gas stores, they can find that themselves. And the rest they use as alternative energy sources such as wind, burning of peat moss and biomasses that they can get in the form of wood, probably from their forests, and other waste fuels. So really, they're only taking about 20% of dirty sources of energy, and the rest is actually quite clean. So this is hopefully a sign for the future what other countries are going to do to minimize the production of greenhouse gases and become cleaner. And the best thing about Finland is most of their energy sources are domestic. They don't have to worry about importing a lot of their fuel from their neighbors, okay, so they can power themselves. So that's a really important thing to think about, and why it's important to learn about this stuff, because economies are run by, economies and wars are dictated by energy and fuel. All right, so if a country can fuel itself and not rely on other people, it'll be quite peaceful there, hopefully, in Finland. All right, so as we read in your text, the first thing you're going to see is they talk about primary energy versus secondary energy. Well, primary energy is the energy sources that we find in the ground, okay? And we don't quite use all those energy sources directly. I don't power my car with coal. I don't power my car with nuclear fuel, all right? But I do power my car with heat or electricity. So primary energy is just the energy that we feed into a power plant, okay? And it's usually found in the ground in the form of fossil fuels, such as crude oil, natural gas, wood, or coal. Okay, wind, hydro, solar are also primary energy, okay, that are then converted into a secondary energy form that we use in our machines to do work. So secondary energy is a processed form of energy that can be used directly to power machines to perform work. So they often use electricity, heat, or kinetic energy. Now there's some of these primary energy sources like wind that move a turbine that can turn a wheel. Okay, so that source can go directly into my machine. That would be pretty neat. I'm not going to waste a lot of energy. But for most of our machines, we have to do something to the primary energy source, such as burn it, and in that process convert it into a secondary energy source, such as electricity. And when we do those things, often the more transitions that happen between primary and secondary to then move my car, often that becomes a wasteful process. So not all the energy that is stored in these things actually goes into moving my car. We lose some of that energy, and you'll see that in the next video when we talk about energy degradation and mapping all the energy lost in these conversions. All right, so important to understand the difference between primary and secondary energy. And then another thing we look at when we talk about fuel sources, well, which fuel source are we going to use for the process? Would it be better to use oil, diesel, or gasoline in my car? Well, fuel sources are rated based on how much energy they contain inside of them, okay? And one way I can look at energy contained inside of a fuel is to rate how much energy, if I burn it, how much energy is going to be released per kilogram of fuel. And that is called your specific, like specific heat capacity. It's your specific energy. Specific energy is the ratio of heat released, megajoules, see that's a lot of heat in these things, per kilogram of fuel released. That's my specific energy. Now energy density, which is not in this table, is going to be how many megajoules of energy is released per meter cubed of that fuel, okay? Because some of these fuels, such as oil, are liquid, and we don't often weigh them. We let them flow in a pipe. So if I had 1 cubic meter of oil and I burned 1 cubic meter, that would give me how many megajoules are in 1 cubic meter, and that would be the energy density. Whereas specific energy is a way of rating fuels due to the ratio of energy released per kilogram of fuel. So if I take a look at this list, okay, these are just plastics that we would burn, very wasteful process. Okay, all these plastics would release around 40.3 megajoules per kilogram, but you don't often see us burning plastic because it's very toxic. But what you do see us burn is wood, coal, oil, and natural gas. So of these, you can see that, wow, natural gas has a lot of energy stored inside of it. Okay, fuel oil also has a lot of energy, 48.6 megajoules per kilogram. But coal per kilogram is not so much. So to get the same amount of energy, I got to burn a lot more coal than oil. All right, so that means I got to store mountains and mountains of coal near my power plants if I want to get the same amount of energy out of it in terms of oil. So it's a lot more popular to have oil power plants because they can be more compact. I can get more energy per kilogram of fuel that I burn versus the coal ones. But coal we can find everywhere in the world, so you can't find it all in oil, so that's why we have so many coal power plants in the world. So it's important to know roughly the differences between specific energies of different types of fuels. Natural gas and oil has the highest energy density compared to different types of coal. Okay, you can see here anthracite coal, which is the most compact form, has more energy than the lightest coal, which is lignite coal. It's like a very brown, dirty coal. All right, and if these coal are contaminated with water and other things, that energy density becomes weaker and weaker and is not as useful. Okay, so we rate the amount of energy in fuels based on these criteria. Okay, and the last thing we'll talk about in this video is the difference between renewable versus non-renewable resources. So all these resources here are non-renewable. They're in the ground. It takes millions of years to produce this through the processes of heat and pressure in the ground. When dinosaurs or organic matter dies and gets covered up without the presence of oxygen and exposed to heat and pressure, it'll be converted into oil. Slowly, wood will be converted into coal, which will then be converted into oil. And that takes a long time. So if we burn it quickly, we're not going to produce it fast enough. So all these resources, fossil fuels, are non-renewable resources. They're going to run out, and they get more and more expensive as we use them. So a push is to start using more renewable resources like Finland, such as wind, hydro, geothermal, and solar energy. That'll be around for a very long time. If we use that, then we don't have to worry about running out of those precious fuel sources. And a lot of these are cleaner, okay? So for the rest of these videos, you're gonna learn how to construct power plants, that use fossil fuels to make electricity, and you're gonna learn how to then make a hydroelectric power plant, a wind power plant, a geothermal, and a solar power plant. And better yet, you guys are going to do a little project where you're going to make a presentation to show us how it's made. All right, stay tuned. There'll be a few more videos coming up to help us show you the calculations and processes involved in this unit.